Hi there. This is Frazier Nyasuru again. So now we look at the Excel spreadsheet. You'll download this from Blackboard. In Blackboard, look under Data Analysis in the left-hand column. And when you go to Data Analysis, you click on Lab 1 Statistical Analysis and download an Excel file. And it will look like what we have here. We're dealing with data, so data is put in the yellow. The calculated items are put in the orange. And whenever we need to round off calculated results appropriately, we will then use, you'll know that that's the case from the blue. All right, so let's see here. So let me click in one of these. All right. What I have here is a cell. The address for the cell is column G and row number 19. So over here, you'll see G19. This is orange. We want a calculated value. And for this, we're considering cylindrical rods. And the data is given here. Here's the diameter. Here is the length. And so here, these are in millimeters, and this is in centimeters. So if I go here, and I want to calculate radius, it obviously comes from diameter. So to tell Excel that you want to do a calculation, go equals. Otherwise, I think it's text. Equals. All right. Then I click on the diameter that I want to do. It says E19. What do you want to do with the entry in E19? I want to divide. And because I'm dividing by two things, for now I'll put a bracket or parenthesis. I want to divide by 2. That's going from diameter to radius. And times is the star. And I'll divide by 10 also because we're going from millimeters to centimeters. And then divide times 10. And close the bracket and then hit enter. It does the calculation. Then I think about whether the calculation is right or not. Now, what I'm going to do here is I'm going to go to the corner here until I see a plus sign and then drag down. It'll then paste the results for the calculations in the other cells. Essentially, the formulas roll unless you tell them not to. All right, so let's go here. Diameter, height. We're going from millimeters to centimeters, so equals. Click on the height. Divide by 10, enter. And for volume, what's the volume of a cylinder? Pi r squared h. And so I'm going to type in the value of pi for now. 3.142. Oh, I didn't put in the equals. Equals 3.142 times the star thing. By the way, all these directions are given in the lab manual, as well as the answers. So you'll know whether you're doing things correctly or not. So times, I'm going to click on the radius, pi r squared h. For the squaring, I'll do the caret thing above the number 6. Square, then times h, click on the h, then hit enter. Then I can highlight these two together, or you can do them individually. Drag and drop. There it is. Density equals mass divided by volume. All right. And then I can drag and drop. No wondering, we don't care what the number of decimal places or significant figures here. Now for average, when the average of the density, go equals, type in average. Now, for now, type in, don't use the functions that go here. Sometimes it's confusing when you're starting out. Just type in average, open a bracket, scroll over the numbers you want to average, close the bracket or parentheses and hit enter. For standard deviation, you go equals STDEV. How do you know that? These functions are defined in your lab manual. Scroll over the numbers. I want to find the average, the standard deviation of, close the bracket, and hit enter. Now let me mess this up a little bit. If I go here, you can see I can change the number of decimal places. So let's say it comes off that way. The rule in the blue cell is you first go to the standard deviation and make that one significant figure. And you can do that by playing around with this. So, okay, go, I'm looking for 1. Ha! I have 1. Then this thing here, the density must be the same number of decimal places. So that's with a caliper, an instrument that you're going to use in the lab. It just gives you more realistic, significant figures. I'll skip the next table because it's pretty straightforward. Let's go to this one. What are we talking about then? Well, we're going to give you what are called autopipetters. Autopipetters, in our case, are a way to precisely deliver small volumes of solutions. And so we'll set our autopipetter to deliver 1 milliliter. And so we'll go to a mass balance, turn the balance, read 0, 0, it reads 0, 0, add 1 milliliter, record the mass, and so on and so on. And if you do that 10 times, you get this data. And so for density here, you can go equals that number divided by that number in the Bureau of Excel. In this case, we want the formulas to roll. I can just copy and paste. There it is. Moving along, not bad. So if I had 1,000 data points, I could calculate them in one scoop. Average equals average. Type in the whole thing, open a bracket. Okay, let's go high, scroll over those, close the bracket, hit enter. Standard deviation equals STDEV. Open a bracket, scroll over the numbers, hit enter. There it is. Now, in this case, look at what we have in the standard deviation. One significant figure, that's 3 decimal places. So this number must be 3 decimal places as well. Now, what we want to do is calculate the 95% confidence interval for the mean. Look up the formula. The formula for this is the mean plus or minus t times s over square root of n. So we can look up the appropriate value of t from the t table. Let's see if I can find it. There we go. Table, where are you? All right, 95%. And we have 10 data points. So the appropriate value of t then is 2.262. All right. Going back to the Excel, I type in 2.262. Then here I'm going to do the TS over square root of n. So I go equals t times s, which I calculated above here, divided by 10 to the power 0.5. That's the square root. All right. This is appropriately formatted. One significant figure. So when I come here, I go equals, click on the average, and hit enter. What does this mean? Here is the statistical significance of what we've done so far. What this says is, if you go do the work and you do it appropriately, then if you process these 10 measurements as I have done, there is a 95% chance that the mean of the 10 measurements will be 1.041 plus or minus 0.001. This means you have a great idea of what you're actually going to get. All right. Now let's plot a graph. Here is a volume, that's what we control, and here is a mass that results from the volume. Let's highlight the mass, and then you wanna go insert, and again these directions are in your lab manual. Insert chart. If you go on the charts here, you want to pick the XY scatter. There it is. But we didn't tell Excel what the Y values are, the X values are. We highlighted only the Y values. So if you click within the graph and right click and go select data, you then have a way to tell Excel the correct X values. So you go to edit, and then if I go on the X series X values, I can then scroll over these to tell Excel the correct X values, and I go OK and OK, and there is the plot. What we also want in this case is to connect the points and the equation of the line y is equal to mx plus b. If you now click on the points and right click and go add trend line, it'll give you options. One are linear, that's the default, and if you go down here, click on the last two boxes, and then you can close this, and there is the equation of the line. Is the rounding correct? Not here. But anyway, you have the equation of the line. Now, let's move on. We can get the data, the M and the B, SM and SB. Remember I talked about this in the last PPT video. How do we get Excel to give us those values? Oh, by the way, there are other graphing routines, labeling of the graph, that I'm relying on you guys to do on your own or with the help of your TA on that first Thursday of the semester. And of course, as we're doing this, you can always pause and then go back and look at the stuff. So, and yeah, you'll get stuck here and there. That's normal. And then you just come to class that first Thursday, 9 a.m., and there'll be a number of TAs who walk you through the locations where you're stuck. So if you have a laptop or anything like that, be sure to bring it. The leanness function, that's the one that will give us the slope, M, the standard deviation, the slope, and we'll use those to round things appropriately. For this, it's a multi-cell output, so you highlight the entire box, 2 by 3 in this case, and you type in equals leanness for line estimate, open a bracket. You'll see it says, give me my known values of y, then the x values and constant and stats. Whatever that means. In our case, we'll go up here. We'll highlight through the y values and do a comma. Don't do a space. We'll highlight the x values. Do a comma. Don't do a space. Then type in true, comma, true. Never mind why that is. It works. Then close the bracket, but do not hit enter. For this function, you do something kind of strange. You go Control, Shift, hold those down, and then enter. Don't just hit enter, not control. Hold Control, Shift down, hold those down, then hit enter. Aha! There it is. So this says the slope is this. You see that it's the same as the one shown in the graph there. This is the standard deviation and the slope. Intercept, standard deviation and the intercept. These two will help us round off these two appropriately. We're going to look up the appropriate value of t in the t table. This time we have 11 data points. It's two-dimensional, so we'll go to the n-2 row in the 95% column of the T table, and you will find that it's the same 2.262. All right. So you go here for the standard deviation. For this one, you go equals, all you do is T times SM and hit enter. It means then that the M should be rounded off to 3 decimal places. So I come here then on the M and go equals and click on the M and then check that the M displays 3 decimal places. And you can do exactly the same for B. Last exercise. All right, yellow is data. And so we're going to tell you what to do in the cells, in the orange cells. If I go here, this says lambda sub M, and the formula for calculating it is up here. Then I can go equals, well, here's lambda here, divided by C, which is there. Then I hit enter. Then I copy and paste. I come calculate alpha. Alpha, I go equals. Alpha says take lambda sub M, divide by lambda sub 0, which is that one in red. There's a reason why it's in red. I hit enter. And then I copy and paste. No. Go back here. Go back there. Move to the corner until I say that nice plus sign. Drag and drop. And find, oh! It works in the first cell, but not in the rest of them. I wonder why. Here's the reason. For this cell, it uses that number and this number. That's cool. When you get to this one, it tries to use this number and the next one down because they roll automatically unless you tell them not to. Well, if we go down here, there's no number there. So it says, oops, I can't do anything. What we need to do is go back to the previous cell and fix this cell, the number in red. And what you can do then is to go here, and then you can set the formula displayed there. We're dividing by the number in red. Put a $sign in front of the J. $sign. That fixes the J. Put a $sign in front of the 85, the row number 85. That fixes the 85. Now if I do that and then copy and paste, now it works. Beautiful. What do I do here? It says, well, calculate alpha C. So I go alpha times C. And I can copy and paste. This one says, take C minus alpha C. All right. And hit and enter. For this one, it says equals, take alpha C, so click on this one, square it, square that number, caret thing above the number 6, enter 2 for squared, divide by C minus alpha C, which I've calculated in the previous column. Hit enter. Then I can copy and paste them together. There it is. All right. Equals average. Scroll over the numbers on average, close the bracket, hit enter. Standard deviation equals STDEV. Scroll over the numbers on find the standard deviation of, close the bracket, hit enter. There it is. Now, blue cells. So one significant figure in the standard deviation, and that's correct, that's one significant figure, and that's written to the same number of decimal places. You'll note here that if I were to write this number to the -7, then this 2 would be to the -5, then this leading 2 would be 0.02. It moved the decimal place 2 times. 10 to the -5, 10 to the -7. So what it means is this 2 is in line with the 3. Alternatively, you could write both numbers in longhand form, 0.00, and then you'll easily verify that the 2 matches with the 3 in terms of decimal places. At this point, you're done with your work. The other graph here, the directions for it, I'll skip that. You then save the file according to the rules, which is stated up here. 1510, lab number 1, last name, first name. Okay, save that. Then go back into Blackboard, same location where you downloaded your file. You'll have directions there to upload your Excel file. Then your wonderful teaching assistant will grade whatever you've uploaded, and then upload the graded file in that location, and you and only you, when you go into Blackboard, can see your graded file. As you work these things, get stuck here and there. That's normal. On that first Thursday of the first session of the summer, there'll be a number of TAs, and you can work through, hey, I'm stuck here, I need help here, this is not working, what did I do wrong here? And then you can work through the exercise. All right, so again, listen to pre-lab lecture 1, the first one, the PowerPoint, and then after listening to that, come and do this Excel file. Happy learning, my dear friends. This is Frazier Nyasolo, signing off.